All right, so we're going to answer this question. It says find the set of values of k for which f of x is equal to 3x squared minus 5x minus k is greater than 1 for all real x. Okay, so what we're trying to find is where f of x is greater than 1. And we can visualize this, and it's helpful to visualize it. So if we've got something like this, something like that. Now, where is 1? So greater than 1 means that it's above this line right here. It's above the line y is equal to 1. What kind of parabola do we have? We have an upright parabola, and you can see that because we have a positive value in front of our x squared term. So that means what we're trying to find is when is my graph above it? So if it's like this is no good. I want it to be always greater. So for all real values of x, for every value of x, I want it to be above the 1. You know, if I drew it like this, then for some values of x, it's below 1. So I want it to look like it's always above it. Now, I want you to think about this in terms of the discriminant. How many solutions does this have? It has no solutions. It never touches this. You know, if I drew it like this, then it would have one solution. It would be touching the line once. Or if I drew it like this, it would have two solutions. So hopefully you can see what I'm dealing with is I'm trying to get something so that the discriminant has no real solution. So in other words, the discriminant is less than 0. That's what I'm working on. Now, what makes this an interesting question is the fact that we're not dealing with the x-axis. We're kind of dealing with y is equal to 1. So it's kind of been shifted up 1. So what we want to do is we want to manipulate our question in such a way that we can actually think about it in terms of the x-axis intercepts instead of it being here. And the way that we're going to do that is we're first going to write out what we have here. Then I will move the 1 over, and this is the important part. By moving the 1 over, I'm now considering where is this greater than 0. So no longer am I considering where is greater than 1, I'm considering where it's greater than 0. So that means if we kind of think about this graphically, I'm now just considering, you know, where is this above 0? 0 is right here, y is equal to 0. So now it's just a standard discriminant question. So by moving this over and now considering 0, what I'm asking is, well, when does 3x squared minus 5x minus k minus 1, this is equal to 0, when does this have no solutions? And it has no solutions when the discriminant is less than 0. So as you can see, I've manipulated it in such a way, so now I can just talk about when is it above the x-axis. So in other words, when is it greater than 0? Okay, once I've done that now, I now identify what B is, what A is, and what C is. My B value will just be -5. That's my B value. What's a -5 squared? It's 25. Then I need to identify my A value. My A value will be 3. So that means I'm going to put a 3 there. And then what is my C value? What is my C value? My C value is going to be -k minus 1. And all of this is less than 0. So that means I'm going to get 25 minus 12 -k minus 1 is less than 0. 25 plus 12k plus 12 is less than 0. That means I'm going to get 12k plus 37 is less than 0, which means I'm going to get 12k is less than -37. K is going to be less than -37 on 12. So k is less than -37 on 12. That is my answer. All right, we'll pause here and we'll go into the next part. I do think it's useful here if I do show you what this looks like on Desmos. I know obviously in an exam 1, you wouldn't be able to graph this at all, but just as we're learning here, I think it's really helpful to get a good sense of what you're doing. So let's just come down here and have a look. So here is Desmos. So as you can see, if I just add a slider here, you can see we've got a graph, and I've moved over. So it's, if I don't do that, let's just put this, let's go here. Let's go y is equal to 1. So there's y is equal to 1. And what I'm saying is that if this value is negative 37 on 11, oh, sorry, was it on 12, sorry, on 12. Do you see how it's exactly touching that line? And then what I'm saying is that if it's less than negative 37 on 12, so if this is more than negative that. So if I come over here, that slider, let's get rid of that. Oops. So if I make it less than that, do you see how it's now above it? And if I make it more, it's below it. But if I make it less than negative 37 on 12, it's always above that line right there. So that's kind of a visual of what you're doing. And then what we did is we minused 1 to this equation, and therefore we were just considering where is it above the x-axis. And as you can see, once again, if it's above negative 37 on 12 or less than negative 37 on 12, it's above the graph. When it's greater than negative 37 on 12, it's below the graph. Okay, obviously you can't do that in the exam, but I still feel that it's useful just to get your head around this question. All right, hopefully you found part A helpful. I'll see you in part B.